All right. We are starting a new unit. We are moving on from a ton of vocab words, and we're going to start feeling in our heart logic, basically. So today we're going to start conditional statements, which have a lot of symbols attached to them. So what I'm going to do is I'm going to have a little section over here for what our symbols all mean, and then a couple definitions, and then we'll do some examples. If you want more examples, I might just do it ahead of time, but I think you might be okay. So email me if you want more examples, and I'll do a heck ton. And then once we get in class, we're going to do some more. So let's just start off. I'm going to put my little section over here. I don't know how big it's going to be yet. So P, normally in math, we have like X's and Y's. We're getting into logic now. So we're going to start with P's and Q's. P is our hypothesis. Now you might know the word hypothesis from science because they use hypotheses all the time. Hypothesis is something that might be true, right? It might. So for example, my hypothesis might be, it might be raining. It's raining is a hypothesis. It's not currently, but it heckin' sure was this morning. Am I saying heckin' so much? I don't know, I'll stop. Q is the conclusion. Why we don't use H and C? I wish I knew. What a great question you just asked me there. Okay, so what we're going to do is we're going to use a lot of things with this arrow in it. And that arrow is just a conditional statement, which says if something, then something else. Most commonly, it's if P, then Q, but occasionally we'll change it up on you a little bit. Who knows? All right, this arrow could also go both ways. That says something if and only if something else. So it's usually P if and only if Q, but I promise we'll get to it. If this doesn't make sense yet, we're good. Don't stress about it. I guess I didn't need that long of a line because the last thing I want to tell you about is this squiggle. This squiggle is going to mean a lot of things in geometry. In the logic section of geometry, this means not something. It's not raining. It's not windy outside. It's not 37 degrees. It's not a right angle. It's not. Okay, so that's our little section that I wanted to give you. Oh, I do need some more room because this one, this is called a bi-conditional statement. And yesterday was bi-visibility day, so I should have done this lesson yesterday. Shoot. It's a bi-conditional statement. Oh, look how beautifully that fits. Okay, so the other thing I want to talk about is that there's 4 main ways to write a statement. One way, I'm just going to do this, is a conditional statement. And that is just P, if P then Q, or P implies Q is how I almost said that out loud. So if P then Q. Another way to write it is the converse. The converse of the statement is that Q implies P. And check my notes really quick. Okay, good. Because the next one is the inverse. And the inverse says that not P implies not Q. And I'm going to show you an example of all 4 of these, I promise. The last one is the contrapositive. And I've already made these both switch places, and I've made them both opposite, so not. Contrapositives both, not Q and not P. Why do we have all 4 of these ways to say a sentence? Because the logic is different for each one of them. So in some things, the converse and the inverse and the contrapositive might all be true. And some of them, they might not be true. So we're going to go through an example where we figure out what the truth value is of a specific statement. We're going to do one with math and one without math. We're going to start without math because I want you to have the logic behind this. I'm less concerned about whether or not you remember that a squiggle is a knot and converse is Q implies P. That's important stuff. But I'm more concerned with whether or not you can reason through why something is or isn't true. That's what I'm most concerned about. And by concerned, I mean ready to teach you. The non-honors classes, I think, are just doing contrapositive. So if one of your friends asks you for help later because they're not doing this quite yet, don't scare them by doing converse and inverse. Just help them with the contrapositive. I'm assuming you're helping your friends with math because you're smart. You're here. They know you're here. They know you're smarter. I mean, you're not really smarter. You're just different. That's okay. Okay, so let's do an example. We're going to write, how do we say this in the book? Hold on. We say that they're related. So we're going to write the related, statements and determine the truth value. Okay, so I'm going to give you the P and the Q already. So my P statement is going to be, it's sunny. Normally we have to write like it is sunny, but... And our Q statement is going to be, I do not need a jacket. All right, so we're going to start with our conditional statement. By the way, you're going to hate this homework just because there's so much writing, but type it. Copy paste. Why make this harder on yourself? So that's going to be P implies Q, or if P then Q. So I say if P, it is sunny, then I do not need a jacket. Is that true or false? If it's sunny, then I do not need a jacket. Here's why I do wish we were doing this in class, because somebody's going to argue with me and I'm super excited about it. So what do you think? I think this might be true. If it's sunny outside, I do not need a jacket. But somebody in class would normally tell me that sometimes it's sunny, but it's still cold, so you do need a jacket. These things are these things aren't always cut and dry of true or false. So if it's sunny, I do not need a jacket. I'm going to say that that's false because you're probably right. That if it's sunny outside, it might still be cold, especially in Washington. Now, if I specifically said it was if it's sunny and 90 degrees outside, I don't need a jacket. We're not wearing jackets outside when it's 90 degrees. All right. Our converse statement is going to be the other way around. Q implies P, which says if Q, I don't need a jacket, then P, it's sunny. Is that true or false? If I don't need a jacket, then it's sunny. I could need a jacket, or I could not need a jacket because I'm inside, even if it's like winter. I really wanted this one to be true, but this might also be false. If I don't need a jacket, then it's sunny. Yeah, I'm going to say that one's false too. And I can always argue about this with anybody because I love these kinds of things. So it could be that it's true. Argue with me. Email me that you're mad about it. The inverse, this is where it gets kind of fun. We're going to put knots in there. And I don't mean knots like how the cat ties up my neck or my strings when he plays with them. So the inverse is that not P, then not Q. So I'm going to put a knot. Now, here's the thing. Here's what messes people up. The opposite of sunny isn't raining or snowing. The opposite of sunny is just not sunny. So what I would say is if it's not sunny, Okay, if it's not sunny, then, and then it's the same kind of thing. Not needing a jacket isn't the same thing as like wearing a bathing suit or something. Because there's two knots in there, I can just take the other knot out. Then I do need a jacket. Do we usually say things like do need? Not usually. I would normally rewrite this to make sense with the beautiful English language that we use. So I might actually say if it's not sunny, then I need a jacket. Okay, is that true? If it's not sunny, then I need a jacket. All these are an issue because when I wrote them, I assumed that I would be outside, but in my head, I heard somebody go, I'm inside, I don't need a jacket. This is probably also false. That hurts me a little bit because my assumption was that some of these would be true. And that's generally the case, is that two of them are true and two of them are false. And I'll tell you which two. And then the contrapositive just flips this entire sentence around. So it's not Q implies not P. So what I'm going to do is if I need a jacket, then it's not sunny. Now this is probably false because of the way that I talked about the first one. If I need a jacket, it could be because it's cold inside or something like that. I do really want to say this one's true, but I think somebody's going to argue with me that it's probably false. Now here's the deal. If you think that these the first one and the last one are true, and you could argue it, I would totally accept that as an answer. A lot of these are going to be based on your the way that you tell me you think about something. All right, I'm going to color code this later, but I want to do one more that has the biconditional statement in it. But I also want to tell you one secret. The conditional statement and the contrapositive will always have the same truth value. So if the conditional statement is true, the contrapositive is true. And that's how we can check to make sure something's true or false, is we can look at its opposite and check. Same thing's true for the converse and the inverse. If one is true, the other one is true as well. So that's how I knew that two are normally true and two are normally false, but it could be anything. All right, hold on. All right, there we go. I just had to adjust the screen. So biconditional statements are useful for definitions. So I'm going to give you a definition, and then we're going to rewrite the definition as a biconditional statement. And these just clean these up a lot. And something's a biconditional statement is if all of these are true at the same time. That makes it a definition, because if it's true one way and the other, it's a definition. I'm going to write it out. Now I shorten this a little bit in the book. It's like if two angles are complementary, then the sum of the two angles is 90 degrees, or the sum of the measures of the two angles is 90 degrees. I don't really care that much. It's fine. So my biconditional statement is going to take this if basically and put it with the then. So I'm going to ignore the if. So I'm going to go, P, if and only if Q. So two angles are complementary if and only if the sum of the measures of the two angles is 90 degrees. So I took the if and the then, and I just replaced it with if and only if. If and only if. Which means that this goes both ways. If the sum of two angles is 90 degrees, then the two angles are complementary. That's all it means, is it goes both ways. All right, I hope I didn't confuse you too much. Please let me know if you have any questions or want me to do any other examples. I will do that. I'm going to color code these before I put them on the notes down below, So the little blue circle with the notebook in it is my notes every time. So you can check there. And you can see how I color coded this because I don't want to do it on camera. But I hope that helps you. And again, please don't stress about whether something's true or false. Just be able to argue it. Tell me what your thinking is, okay? And then, oh, please don't spell angles ELS. It hurts me. Those are angels. They fly in the air. Angles don't fly in the air. There's a bunch of puns about it. So don't do that. Okay. All right. I'll see you in class. Goodbye.